So let's talk about this same chemistry from a processing standpoint, right? I mean, there are some challenges and there are some pretty good solutions to those with regards to both liquid and solid systems. Let's start with liquid monoanhydrides. Vinay, speak to processing and what you see as advantages for that type of curative.
Yeah, so actually the liquid anhydrides that are commonly used these days are actually designed for that purpose, that they're liquids and easier to handle compared to the maleic anhydride and phthalic anhydrides of the past. So these systems, the monoanhydrides, they are low in viscosity, and then when they are mixed with the epoxy resin, that brings the mixed viscosity down also. And that enables you to have easier fiber wetting, and it makes it a lot easier to do all kinds of fabrications. And the other benefit of these anhydrides, or probably all anhydrides, is that they do not react readily at room temperature with epoxy resins. So that gives them a lot of open time to take care of the fabrication process. You can use a lot of complex processes if you have to, depending on the complexity of whatever you're making. So these are the benefits that allow you to use these kinds of systems for all kinds of composite applications.
So I mean, there's nice compatibility there, but now we talk to dianhydride solid systems, and I mean, you've got two different things, right? You've got how to incorporate the solid dianhydride into a liquid epoxy resin, and then you've got actually purely solid systems, coating powders, for example, where that's a total non-issue.
Right.
But on the issue where you've got to try to deal with a solid particle of a certain size and put it into a liquid epoxy resin. And then what can you say regarding, mixing techniques and offering some advice in that regard?
Yes, and to Vinay's point, the advantage of liquid anhydrides are that they cut the formulated viscosity quite low, and that way you avoid the use of diluents.
Exactly, yeah, that's something that we didn't mention, yeah.
Whereas with solid anhydrides, you could still get the viscosity down, and to Vinay's point, at ambient temperatures, the reactivity is not very high. So you could gently warm the epoxy system and incorporate thoroughly and uniformly your solid anhydrides, and then make the formulated system that way too.
And it doesn't take much. I mean, I think a lot of people panic. They're like, how do I get this, and then
no, but at 35 or 40 degrees, you reduce the viscosity enough.
Exactly. Yeah. The temperature viscosity, the curve is pretty steep. So just about 35, 40 degrees Celsius, you're able to get this liquid enough that you could thoroughly incorporate your solid anhydrides.
And if you're using something like a micronized powder, I mean, that's going to facilitate even more.
That's important.
That's important.
So I think that's a misnomer that people just panic. Oh, solid into liquid. What do I do? I mean, it's since time immemorial. But simple suggestion how to incorporate easily with gentle heat. You're almost overthinking, and it's like, no, there's a very easy way to do this.
And that way you don't incorporate too much air into the system by shear mixing.
Yeah, exactly.
Absolutely.
High shear mixing.
Yeah.
So.
Okay, so then let's go to like the holy grail now. Let's put them all together. So you've got a solid dianhydride, monoanhydride. What's a best of both worlds situation where you can combine them?
That gives you with using a co-curative like liquid monoanhydride, you've already reduced the viscosity of the epoxy. It's going to make the incorporation of the solid dianhydride into the mixture much easier, particularly as a small particle. And again, you can do it at room temperature, slightly elevated. You're not going to start the cure process. Give you some decent pot life to be able to use the material in whatever way you want to use it.
But we've encountered before where you take a solid dianhydride and you put it into a liquid monoanhydride, and you figure, well, I'll just make it so it's a nice slurry so I can get it into my system. But in those cases now, we just a small discussion about dosing levels and stoichiometry and so on. I mean, you've got to have a certain amount of the dianhydride in order to get the benefit. Otherwise, it's just going along for the ride. So people may say, oh, liquid systems, I want some milky dispersion. It's like, no, you've got to make it slightly different, but still very good for processing.
Depending on the form, we've seen things that are pourable pastes or pumpable pastes, depending on the loading of the dianhydride and the monoanhydride mixed together.
Sure.
Very manageable on any scale you want to use.
Yeah, put it in a pressure pressure pot, low
Yep.
pressure, just dose it into the system, and now you've got both mono and dianhydride working together.
And the monoanhydride is really a reactive diluent
Yes,
for
exactly.
the highest loading of BTDA or
Yep.
dianhydride
Yeah, it's a very
that you can
elegant
get
solution.
in.
Yeah.
And which and you choose the monoanhydride from the family of those liquids in a way that itself would give you the highest TG
That's right.
possible, highest
Absolutely.
temperature resistance
Yeah,
possible
and
to
I
begin
think
with.
that's important, your point of talking about it as a reactive diluent as opposed to a simple diluent, which then can cause problems later on with processing. You've got to displace it, get it out of the system, but not cause voids and all this
Right.
associated.
So that in and of itself requires some formulating expertise. I mean, not
Absolutely.
just so much the wider epoxy system, and now we're talking about how to put the dianhydride and
Yep.
the monoanhydride together, optimally paired for
the right
good,
ratio.
good introduction, good processing, good good metering and mixing.
Yep.
And that's a method of utilizing a reactive diluent on the B side.
Yeah.
Yes,
Exactly.
yeah. It's elegant and it works and it cuts one product out.
It gives you, basically almost a one-pot product too. You've incorporated into a uniform system. Yeah.
Just add simplicity.
Yep.
Yeah, keep it simple, right? Yeah. Okay.